In figure, K is given as 100 Newton per meter, mass is 1 kg and force is 10 Newton. Find the compression of the spring in the equilibrium position, right? So first of all, at equilibrium position, this is my block M, a force F will act in this direction and a force Kx will act in this direction. So for equilibrium position, F is equals to Kx. F is given me as 10 Newton and K is given as 100 to X. So X comes out to be 0.1 meter or 10 centimeter. Alright. In second part, I had to calculate a sharp blow by some external agent imparts a speed of 2 meter per second to the block towards left. Find the sum of potential energy of the spring and the kinetic energy of the block at this instant. Alright. So the total energy at this one instant can be written as half of K x square plus half of m v square. So to substitute the value, I have half of K is equals to 100. The value of x is 0.1 meter as I calculated above, plus half of mass, that is 1, into the velocity, that is given as 2 meter per second square. So the total energy comes out to be 2.5 joules. Alright. In C part, find the time period of the resulting simple harmonic motion. Fine. Now the time period can be written as 2 pi under root of m by k. It is not at all variated by an external force, because the time period, it depends only on the mass and the spring constant, irrespective of if any external force is acting on the particle or not. So just substitute the value. Mass is 1, K is 100, so it comes out to be 2 pi by 10, that is pi by 5 seconds. In D part, find the amplitude. Now I do have to calculate the amplitude. For I should write the energy conservation equation. Okay. Now at equilibrium position, I know the total energy, that is given by 2.5 joules. This is the energy at a position A. Fine. And after it reaches the extreme position, the energy of the spring can be written as half of K, let's say x plus delta whole square. This is the total energy of the spring at extreme position. That will be equal to the energy at the mean position, that is half of K x square plus half of m v square plus the work done by the external force F in traveling this distance, and this distance is nothing but delta. So this is F into delta. So just substitute the values, right? So I have half of K is 100 into the value of x is 0.1 plus delta whole square plus half of 100 into, okay, the sum of both this half of K square plus half of mv square can be written as 2.5 joules, as I have calculated this in B part. So it is 2.5 plus F, that is given as 10 into delta. So to solve this equation, you get a quadratic, and solve this quadratic, the value of delta will be coming out to be 20 centimeter. That is my answer. That is the amplitude, because we know that at a distance x, that was the mean position, and by further distance delta, that will be an extreme position. So this delta will be the amplitude. Okay. Now in E part, I have to calculate the potential energy of the spring when the block is at left extreme position. So at left extreme position, there will be only and only spring energy, that can be written as half of K x plus delta whole square. So just substitute the value now. Half of K 100 into the value of x is 0.1 and the value of delta is 0.2 whole square. So the value of E comes out to be 4.5 joules. Right. Now in next part, I have to calculate the potential energy of the spring when the block is at right extreme position. So I can write the potential energy of the spring at left extreme is equals to potential energy at right extreme plus some work has been done by the force, that will be equal to the total displacement, F into total displacement from z extreme to right extreme. So the potential energy at left extreme is 4.5 joules minus the force, that is 10, into total displacement. The total displacement will be 2 times of amplitude, so it will be 40 centimeter or 0.4. That is the potential energy. So it comes out to be the potential energy at the right extreme will be 4.5 minus 4, that is 0.5 joules. That is the answer. Now it is asked that the answer of B, E and F are different. Now why it is happening so? Because although the principle of conservation of energy is applicable, but an external force is constantly acting throughout the motion. So even the principle of conservation of energy is applicable, but there is an external force acting. So therefore the potential energy or the total energy at point B, E and F are different.